students, welcome back to my lectures of class 11th physics. We are studying our chapter motion in a plane. Okay, in the previous video we have seen the resolution of vectors, means the splitting of vectors along the different axes. Okay, now here we will see the application of resolution of vectors. The first application is the walking of a person. Okay, जब भी आप walk करते हो, in that case you push the ground with a force F. Okay, now in class 9 we have studied the Newton's third law of motion, that is to every action there is equal and opposite reaction. मतलब जितना force आप ground की तरफ लगाओगे, with the same force the ground will also push you in the opposite direction. Okay, and that is represented as normal reaction. Okay, so here opposite to this force we have another force that is called as the normal reaction or simply the reaction force. This reaction force that is exactly in the opposite direction as that of the force with which you are pushing the ground. क्योंकि अगर आपको आगे की तरफ चलना है तो आपको वहां पर फोर्स लगाना पड़ेगा. Okay, now here I can assume कि यहाँ पर this is the straight line. Okay, here I have another straight line and you can assume this to be along the x-axis and this is the y-axis. Now we are assuming कि यहाँ पर ये जो एंगल है, this angle is the theta. मीन्स ग्राउंड के साथ जो नॉर्मल रिएक्शन जो एंगल बना रहा है वो कितना हो गया, थीटा. या फिर आप ये भी कह सकते हो कि ग्राउंड के साथ ये जिस एंगल पे आप फोर्स लगा रहे हो दिस इज एंगल थीटा. Okay, now here this normal reaction and this angle theta we have, then we can resolve this normal reaction along the two different axes. यहाँ पर क्या हो जाएगा, it will be r cos theta, this is the force that is vector quantity, and here it will be r sin theta. Okay, so here we can say this normal reaction is splitted along the two axes x and y. Along the x axis where we have theta, that is r cos theta, and along this side we have r sin theta जहाँ पर हमारे पास एंगल नहीं है. Now here this r sin theta that is balanced by the weight of the person, क्योंकि weight का डायरेक्शन क्या होगा, नीचे की तरफ होगा. Okay, so this component of r sin theta that is balanced by the weight of the person. Now we have another component that is r sin theta which is in the forward direction. So this component r cos theta that enables the person to move in the forward direction. और ये भी कब होता है, कब, जब ये r cos theta it is greater than the frictional force. ओके, क्योंकि आप जब आगे की तरफ मूव करना चाहोगे तो यहाँ पर क्या होगा, देयर विल बी फ्रिक्शन फोर्स. अगर वो फ्रिक्शन फोर्स ज्यादा हुआ तो आप आगे की तरफ मूव नहीं कर पाओगे. ओके, और फ्रिक्शन फोर्स कम भी हुआ तो भी आप आगे की तरफ मूव नहीं कर पाओगे. सो इफ दिस r cos थीटा दैट इज ग्रेटर देन दी फ्रिक्शनल फोर्स, अगर ये फोर्स फ्रिक्शनल फोर्स से ज्यादा है तभी आप आगे की तरफ मूव कर पाओगे. So out of these two components of the normal reaction, only this component r cos theta that enables you to move in the forward direction, and that too when this component r cos theta that is greater than the frictional force. So this is the application of the resolution of vectors where a person is able to walk only because of the resolution of vector. Now the next application of the resolution of vector is the lawn roller, where we have to see that is it easy to push or pull a lawn roller. Okay, उसको या तो push करने में easy होता है या फिर pull करने में, ये हमको देखना है. Okay, so here we have two different cases. The first one is that the height of person is the less than the roller, and the second case the height of the person is more than the roller. Okay, now here in both the cases we'll see two different cases, that is in the case of push and in the case of pull. Okay, now here we can say, here we'll study here the case of push and here I will draw the diagram for the pull. Okay, here let us assume that this is the lone roller and here the height of person is less than the roller. तो यहाँ पर height of the person is the less. Okay, here this is the center one and assume that this person holds this roller in this direction. Okay, this is the handle of this roller. Okay, now it is the case of the push, means this person is pushing this roller in the straight forward direction. तो यहाँ पर ये जो force है इसका direction भी क्या होगा, it will be along this direction. This is the force F. Okay, now I can assume that this is the horizontal line which is passing through its center. Now in the case of this lone roller, we are always considering the angle theta with the horizontal line. मतलब यहाँ से हम angle theta consider कर सकते हैं. Okay, now here at the same center point, I will draw another axis. Now why I am drawing these two axes? Because I have to resolve this force into two perpendicular direction. अब यहाँ पर अगर एंगल थीटा है तो इस डायरेक्शन में जो फोर्स होगा इट विल बी एफ कॉस थीटा. जहां पर एंगल थीटा है वहां पर कॉस कंपोनेंट आता है, और जहां पर एंगल थीटा नहीं है along this direction I can write f sin theta. Okay, now here in this downward direction, here the weight of the roller will act, so I can write this as the W. Okay, now here you can see this weight is acting exactly in the opposite direction as that of f sin theta. मतलब दोनों क्या है, vectors है, and both are acting in the exactly opposite direction. So here the resultant weight, or you can say the effective weight, क्या हो जाएगा? स्टार्टिंग में जब तक आप फोर्स नहीं लगा रहे थे तब उसका जो वेट था वो कितना है, W. लेकिन अब क्या करेंगे कि ये जो f sin theta है, it is acting in the exactly opposite direction as that of weight W. Okay, so here this effective weight will be W minus f sin theta. ओके, सो यहां पर हम कह सकते हैं कि इफेक्टिव वेट पहले क्या था, W, बाद में क्या हो गया, W माइनस एफ साइन थीटा मीन्स दिस इफेक्टिव वेट दैट डिक्रीजेस. ओके, नाउ वी विल सी द केस ऑफ पुल. क्या होगा यहाँ पर, हियर वी आर अज्यूमिंग दैट वी हैव दिस लॉन रोलर, दिस इज द सेंटर ऑफ दैट रोलर, एंड वी हैव अ पर्सन हु इज स्टैंडिंग हियर. नाउ इट इज द केस ऑफ पुल. दिस पर्सन विल पुल दिस रोलर टुवर्ड्स हिम, और जब ये पर्सन इसको अपनी तरफ पुल करेगा, in that case this will be the direction of the force F. Now I can draw the two perpendicular axes along this central line. एक एक्सिस यहाँ पर हो गई और एक एक्सिस यहाँ पर हो जाएगी, and we are considering the angle theta along with the horizontal line. तो यहाँ पर ये क्या हो गया, this is the angle theta. Okay, we are assuming that this angle theta and this angle theta both are same. Now this f can be resolved along the two different perpendicular axes. यहाँ पर थीटा बना हुआ है, in that case here you can write f cos theta, and along this side I can write f sin theta. जहाँ पर थीटा है वहाँ पर cos component, जहाँ पर थीटा नहीं है वहाँ पर sin component. Okay, now here in this direction, that is towards the center of the earth, the weight of the person will act. मतलब यहाँ पर जो वेट है और एस साइन थीटा है, दोनों क्या है, बोथ आर एक्टिंग अलोंग द सेम डायरेक्शन, एंड वी हैव सीन इफ द टू वेक्टर्स आर एक्टिंग इन द सेम डायरेक्शन, इन दैट केस द रिजल्टेंट विल बी द एडिशन ऑफ द टू वेक्टर्स. तो यहाँ पर इन दिस केस वी कैन राइट दैट द इफेक्टिव वेट दैट विल बी इक्वल्स टू W प्लस एफ साइन थीटा. जब तक ये यहाँ पर पुल फोर्स नहीं था तब तक इसका वेट कितना था, W, बट नाउ इट्स वेट हैज इंक्रीज टू W प्लस एफ साइन थीटा. मतलब यहाँ पर जो वेट है वो क्या हो गया, बढ़ गया. सो हियर इफ द हाइट ऑफ द पर्सन इज लेस देन द रोलर, इन दैट केस दिस पुश इज इजियर देन द पुल. सो यू कैन राइट हियर पुश इज इजियर देन पुल. Okay, now we will consider the another case, that is the height of person is more than the height of roller. Okay, now here we will assume this side to be the case of push and this side to be the case of pull. Okay, now here this is the lone roller. Okay, and this is the center of that roller, and here we have that person who is standing here, and this is the handle of the roller through which that person will push the roller. Now this person will push the roller in the forward direction, so I am assuming that with this force F, that person is pushing the lone roller, and here we are assuming that this angle theta is with the horizontal line, and I will assume one more line here, that will be the two different axes. Okay, now here we have angle theta, so we can resolve this force along the two different components. मतलब यहाँ पर इस साइड क्या हो जाएगा, it will be F cos theta, and along this side it will be F sin theta. And here the weight of the person that will act in the downward direction, that will be W. Here these two vectors f sin theta and W, that is the weight, both are acting along the same direction. So in that case you can write here the effective weight of the roller, that will be equals to W plus f sin theta. Okay, so here you can say that the effective weight of that roller that increases because we are adding something in W, that is W plus f sin theta. Now here we will consider another case, that is the pull of a roller. हमारे पास यहाँ पर एक lone roller है and here we have a person, and here the center, and this is the handle of that roller, and this person will pull the roller towards him. तो यहाँ पर जो force है वो कितना हो गया? We are assuming this force to be F and this will be its direction, and we have to assume the angle theta. इसलिए हम यहाँ पर दो particular axis यहाँ पर बना लेते हैं, and we are always considering the angle theta with the horizontal line. तो यहाँ पर angle क्या हो गया? Theta. In both the cases we are assuming the theta to be same. Okay, now here I can resolve this force along the two different axes, that is here F cos theta and here it will be F sin theta. Okay, and here in the downward direction the weight of that roller will act. Okay, now here what will be the effective weight? I can write here this effective weight, that will be equals to W minus F sin theta. Why minus? Because this F sin theta and W, that is the weight, they both are acting in the exactly opposite direction, and when the two vectors are acting in the opposite direction, in that case the resultant will be the subtraction. Okay, here you can see the effective weight क्या होगा यहाँ पर? कम हो रहा है, because we are subtracting something from this W, so the effective weight will decrease. So here you can compare these two, that when you are pulling the lone roller then its weight decreases, but when you are pushing it then its weight increases. So here we can write this pull is easier than push, and here is the case when the height of the person is more than the height of the roller. So here we have two different cases, that is the height of the person is less and height of the person is more. When the height of the person is less, in that case the push is easier than pull. In the same way, if the height of the person is more, in that case the pull is easier than push. So this is all about the application of resolution of vectors, where we have seen the walking of a person and push and pull of a lone roller.